everybody. So according to this watch, it's now 7 o'clock. This is a little ahead, perhaps. Who knows? So now we have invited also for a very particular session, a so-called Science Slam session. And this is quite interesting because this is not as formal as anything else. So this is, the basic idea is that it should be entertaining, and still there should be a scientific story that the speaker wants to convey. We have two people that are stepping up for this here, and it is actually, as everything else, it is a competition. So it's like a boxing fight, so we have room now. And the judges is everybody. Everybody can judge. The way you judge is by giving you applause once in a while. If there are points, who knows? Let's hope that we will find that, and then give your opinion, applause or pew or whatever. So, but I think we're ready to get started. So, in the right corner we have here Brockhoff. So, who is now also since signing up, has become the head of department. So, I'll not introduce anything about the weight or anything, or in this. Good-looking young man. So Per is ready and wants to talk to us if all research is fake news. Is that right?
Yes.
Yes, please.
Thank you. My name is Per Brockhoff, and this is about as much a challenge as when my mother-in-law invites me to do the Toastmastering at family dinners in Western Jutland. And then she says, after I've known her for 30 years or more, and please be a little entertaining, as you usually are. And so, on command, we have to be entertaining. Yes, I am going to talk about fake news. If you Google fake news, I just tried it this morning, fake news, you get 32 million hits. And then I checked, I found a number of how many scientific papers I've written each year. I found a number of 2.5 million. Probably that's not right, but that was a number I found. And then you could start actually speculating how much of those 2.5 million papers are fake. Right, given the pretty scary thought, we could ask ourselves, is that really true? Actually, this is not a new discussion at all, of course. Science has been thinking of that for a long time. This is a paper by John Ioannidis from 2005, 12 years ago, with the title, Why Most Published Research Findings Are False. Pretty catchy title, actually. Here's another paper. This is not new at all. This is from 1959. And it's not because they had better eyes, that is, or smaller printers. But let me just read out the title. Publication Decisions and Their Possible Effects on Inferences Drawn from Tests of Significance, or vice versa. This says something about the importance of communication, right? Now, this reflects the impact, the absolute impact. This one is a pretty cited paper, the 1959 papers, who actually made the point in 1959. And probably someone before that would have made the same point if you understood what statistical method. I forgot to introduce that I'm for 10 minutes a professor of statistics now. Right. And this is pretty well cited, the small one, 700-800. But only 1/5 of this one, 4,500 citations on this one. And if we take it relative, there's going to be a bit of technicality, relative to the number of years, this is the impact, right? This shows something about a catchy title can make a difference. It can also maybe be dangerous. It's a pretty dangerous title, maybe. It can be misused, and I'm sure it is. So before I make it, there is also some very nice points in that paper. I'm going to hope I get the time to share that point with you. But before that, we're going to do a game. I'm going to game you. So make room, right? We're going to warm up. I'm going to ask you some questions, and you're going to raise right or left hands. Left or right hands. And And you're not allowed not to raise anything when we start the game. It's a forced choice game. And it's split. It's gut feeling. Answer it. Don't look at the neighbors or anything. Right? Gut feeling. But let us begin. How many of you had at least one statistics class in your life? How many of you had more than 2 statistics classes, 2 or more statistics classes in your life? Hey, then this is going to be a piece of cake. Here's the story. Listen in. I'll say it only once. We made a small study. 20 persons here, 20 persons here. Right? 2 sample study. We are interested in comparing the means. We compute the means. We could compute the t-test statistics that you're all taught in your first stats class. The t-statistic becomes 2.7, and the p-value becomes 0.01. P-value 0.01. Are you ready for the game? I give you 6 statements, and you're going to say true left hand or false right hand. Right? Here it goes, and it's rapid. We don't have the time to speculate. You have absolutely disproved the null hypothesis. Come on. True or false? You know the probability of the null hypothesis being wrong. True or false? You have absolutely disproved the experimental hypothesis, typically that they're different. True or false? You know the probability that the experimental hypothesis is wrong. Maybe I forget some of the questions, but that doesn't really matter for me. 2 more questions. Given that you reject the null, do you know the probability of you making a mistake? True or false? Last statement, statement 6. You have a pretty reliable research conclusion, in the sense that if you redid your experiment many, many times in the future, you would reject it 99% of the time. True or false? Now I watched you, so you cannot lie to me. Who in here raised your false hands 6 times in a row? Good job. Because you should have. They were all false. They were all false. What the heck is going on? Did the statistics teachers fail completely? Well, yes. Good point there. In fact, these are questions that have been used in psychological research and statistical cognition. Exactly those questions. There are research showing that when you ask people those questions, they're just like you guys. No one really gets it. Right? So what the heck happened to us? No one really gets those probabilities. Yeah, it's because it's probabilities. Probabilities are difficult. Conditional probabilities are extremely more difficult than just probabilities. Actually, the Nobel Prize winner in economics, Daniel Kahneman, used that as his motivation to his work that gave him the Nobel Prize. The challenge of understanding statistical reasoning. How the heck could it be that intelligent researchers don't really get it? And the thing is, he tries to explain that our intuitive system 1 really doesn't get it. I've worked 33 years with this, my system 1. In fact, there's only one thing in life I've studied more. I've studied that for 34 years. These are the complex signals from my wife. And similarly difficult, my system 1 simply cannot handle it. I need to process it with system 2 to survive. So, what to do about it? I wanted to make the point about probabilities. What's really the point about this? And before that, this global confusion about our basic tool of making scientific findings made last year a historic event happening. I'm sure you all saw the news that American Statistical Association, the ASA, for the first time in their more than 100-year history, made a public statement about the p-value and hypothesis testing. 26 experts, including John, writing this paper, and many distinguished statisticians in the US, sat down and worked and discussed, lengthy discussions, many meetings to try to clarify the concept of p-value that we teach in our basic stats class. I don't see that happening for Newton's law or anything in physics. And the conclusion is we should stop doing this uncritical use of the p-value. We should remember, which has always been the point of statisticians, that there is more to it than just a p-value. And we need to remember that. So, what's the point of this, the paper? The paper with the dangerous title has some interesting points. And I know this is dangerous, but I'll try to see if I can do it. To make such points, we need to think about those some millions of scientific investigations of next year that are going to take place, some of them being reported in papers. Now you represent the scientific research, the investigations going on for next year, a number of millions of investigations. We have to make an assumption about those. I assume that you are 44 people. I need a number I can deal with. You are 44 people in here. How about this assumption about the world? There's a 1 to 10 split between the real findings and all the mess. So I need some volunteers. You 4 guys, come up here. You're the real findings of the future, right? All the rest of you guys, you're fake. Right? So now hypothesis testing, I put on my hypothesis testing hat. It has 2 sides. It has the sensitivity side, the power side, and it has the specificity side, the type 1 risk side. Now the power side, actually unfortunately, is not very powerful often. Let's assume that it's only 25% power. We don't know, but let's assume. So the power side and go and check you guys the real findings, but I have only 25% the chance of finding a real thing. So you were the lucky guy. I rejected you, but I didn't find anything. Then you use the other side, like this. This is the specificity side, the 5%, right? 95% specificity, 5% risk, global. You're 40. What's that? 5% out of 40? That's 2. You want to play on? You 2 guys, come here. Fake findings. You come in nature, one in science, and you're in Journal of Food Quality. Now here's the conditional probability, right? Among the findings, among the 2.5 million findings that are actually published, what's the probability of a finding actually being something? 1/3, right? That's the point. So hey, we all knew that. We don't expect those percentages of findings being extremely large, at least under some scenarios of how the world looks. Thank you for participating. You can sit down. That's the point. So I'll finish up by saying, how the heck should we now deal with this? Well, time has gone, so you go check that. Make sure you do good research, because good research is not fake findings, of course. There's a lot to it, how to do the good research, the high power, many cells, so on. And both to make sure that the classical methods and also the new methods are not turning into, I like this book, weapons of mass destruction. How big data increases inequality and threatens democracy. Whoa, big words. How do we avoid that? Well, I'm a statistics professor. There are many answers to this question. We should open the black box. That's one of the, should be open. We should share. And we should not, don't lose the 7 pillars of statistical wisdom on the floor. Several hundred years of wisdom and science that are still the basic of what we do today. So let's not forget that. So thank you.